Okay, guys, we are going to be looking at finding the surface area of triangular prisms and pyramids. So, quick refresh. The surface area of a triangular prism is the area of its net. That's when it's broken apart. And the triangular prism has 3 rectangular faces and 2 congruent triangular bases. So let's take a look and see what we can do with finding the surface area of the example below. All right, so we've got a triangular base here. It's got a base of 6 centimeters, and back over here, the height, which makes a right angle with the base, is 4 centimeters. So I'm going to label that as my height, and this is going to be my triangular base, or B. Now, we have 3 rectangular faces, but they are not all of the same size, okay? I have one that is 5 times 11, one that is 11 times 5, and one that is 11 times 6. So when we pull out the net, that's exactly what we see. 5 times 11, 5 times 11, 6 times 11, and then 2 triangular bases with sides of 5 and a height of 4 centimeters. So what does it look like when we do the math on that? I like to break it down into the face sets. So let's start with the 2 triangles. So my 2 triangular faces, and the area equation for triangles is base times height divided by 2. So I would fill that in. My base is 6, my height is 4, divided by 2, but I'm going to multiply it by 2 because I've got 2 of them. So that would reduce down, and I would simply get 24 centimeters squared, and that is the 2 triangle area part. Okay. Now then I've still got 2 rectangular faces, and those are the ones that are 5 times 11, base times height, whoops, 11, guys. And those are still times 2, so 55 times 2 is 110, and it is in centimeters. And now I've got that one odd rectangular face. That is 6 times 11. And since I only have one, that is 66. And when I put that and add it up in my calculator, I get 200 centimeters squared. Okay? Oh, I forgot to fill this in. So the triangular prism has 3 rectangular faces and 2 congruent triangle bases. Okay. All right, let's turn the page and do another example. So a pyramid has a square base measuring 10 inches on each side. It has 4 faces that are congruent isosceles triangles. Remember, isosceles triangles have 2 congruent sides, and the height of each triangle is 12 inches. And we're asked to find the surface area of that pyramid. So it might be a little easier to work on it from the net, but we need to be able to recognize the different pieces between the two if we're given a figure that's in 3 dimensions versus the net that's been broken out and is in 2 dimensions. But we have a square. We have a square base. So square base. And the area equation of the square base is length times width. So 10 times 10, and that equals 100 inches squared for the area. Now then I have 4 triangular sides. And the area equation for those is base times height divided by 2. But remember, I'm going to multiply it by 4 when I get over here. So I've got a base of 10 and a height of 12 for each of those faces. 10 times 12 divided by 2, and I'm going to go ahead and multiply it by 4, and then this is going to reduce down to 2, so 10 times 12 is 120. 120 times 2 is going to be 440. Pretty sure. I wrote it down. 240, excuse me. So 240 inches squared. Now I'm going to add my square base to my 4 triangle, and I am going to get a final answer of total area 340 inches squared. Excuse me. So again, I would get 100, 10 times 10 for this net. And each of these triangles would be 12 inches of height, 10 inches of base. So 10 times 12 divided by 2, and that will give me 60. So each of these pieces is 60 inches squared. And so 60 times 4 is 240, plus 100 gives me a total of 340 inches squared. So it doesn't matter if I'm given the figure as a 3-dimensional or a 2-dimensional. I can figure it out if I break it down into its pieces. So let's go on to finding the volume of pyramids. Now we have a rectangular or a square pyramid, and we have to know that the height is from this upper vertex to the very center of that base figure, and it makes a right angle. That is height. We're not talking about the height of a triangular face. We're talking about the height of the pyramid itself. So be careful how we use the word height and make sure we know what it means. Okay? So before we can work on the volume of the pyramid, we have to find the area of the base. Okay. So our volume for a pyramid is 1/3 that base area times the height of the pyramid itself. And then we multiply it by 3 or divide it by 3, same thing. And that is going to give us our volume. Remember, our unit of measure, cubed, tells me about volume. So let's look at example 9. And let's work on this base. It's rectangular because these sides are not congruent. So my area of the base is going to be 6 times 4.5. And that gives me 24 plus 3, 27. 27 centimeters squared, because right now I'm still just working on area. And now that I have this base measure, I can go into my volume and say 27 times the height of the pyramid, 8 centimeters. And I'm going to multiply all of that together and divide it by 3. And I should get 72 centimeters cubed. Okay? If you don't believe me, go ahead and do your own math in your calculator now. So 72 centimeters cubed is that volume. All right. Do another couple of things. This time we have a triangular based pyramid, and this is a right triangle. So this is not going to be an equilateral or an isosceles because it's right. But we have a triangle with a base of 5 centimeters and a height of 3 centimeters. The pyramid itself has a height of 6 centimeters, and we are asked to find the volume. Okay. First step, we are to find the base area of that right triangle. So 3 times 5 divided by 2. Let's go ahead and write that down. 3 times 5 divided by 2. 15 divided by 2 is 7.5 centimeters squared. Now I'm going to put that base into my volume. So volume equals my base 7.5 times the height of the pyramid itself, which is 6. All of that divided by 3. I'm going to reduce that fraction and get 2 times 7.5 and come out with 15 centimeters cubed. No. Yes, 15 centimeters cubed. Okay. Which is funny because it just kind of matches back up to the top. It's sometimes the way the numbers work out. Okay, let's try one. We've got a pyramid with the height of 12 meters. So that's the pyramid height. And I've got a square pyramid. Okay, so its base is a square. That's good to know. And a pyramid with the height. And our base measure is 5.5 meters. So 5.5 is the side. That makes all of these sides the same. So I'm going to do my base times base to get the area. So my base equals 5.5 times 5.5. And that gives me 30.25 unit of measure meters squared. And now all I'm going to do is take that base number and put it into my volume. So volume equals my base of 30.25 times the height of the pyramid, 12 meters. All of that divided by 3, and I get a final answer of 121 meters cubed for the volume of this square pyramid. Okay, we still have one more topic to cover today, and that is starting on page 16, and this is the area of a circle. Now, I'm expecting you guys to pretty much remember how to do this, where area equals pi times the radius squared. Okay? Remember, the radius is from the center to the edge, and a chord that goes all the way across the circle through the center point is the diameter. Okay. Okay. The diameter is twice the radius, or the radius is half of the diameter. Either way you want to look at it. Another thing that we seem to be struggling with is the fact that we don't know what in terms of pi means. And we talked about this a little bit in our last unit. So if you are asked to leave things in terms of pi, that means we are not multiplying out pi. So do not multiply can't spell either, by 3.14. Okay? Pi will be part of your answer. Okay? Don't forget that. It depends on what you're asked. Okay? So real quick, let's find the area of a circle with a radius of 5 centimeters. And I'm going to say in terms of pi. Okay? And then I'm going to draw a circle. I got a radius from the center to the edge. That is 5 centimeters. Area of a circle is pi radius squared. So pi, which I'm leaving, times the radius squared. 5 times 5 is 25. My final answer is 25 pi centimeters squared. That's my final answer for the radius of this circle. Okay? Now I'm going to change the direction slightly in number 2. You're going to multiply out pi. And pi we are using as 3.1415. We are upping our game on pi. Y'all are used to 3.14. I'm telling you to go to 4 decimal places, okay? And you are going to round your answer to 2 decimal places. Okay. So what does that look like? Well, area equation, area equals pi 3.1415 times the radius. Well, I'm given a diameter. Well, that's okay. Diameter is simply 2 radii. So I want half of this. That's 9. Still going to square it. And I put that into my calculator, and I get 81 times 3.1415. And my final answer is 254.46. Unit of measure, centimeters squared, because it's area. Okay. Our next example is a composite. Okay. I have a square and I have a circle, and I want to know the amount of the shaded region. So I'm going to take the outermost shape, which is the square, and I'm going to subtract the circle from it, and that is going to give me these leftover bits, and that's what I'm being asked to do. Okay. Circle. So I need the area of a square. Well, we just got finished with that, and that is side times side. So my area of the square equals length times width, or 100. So what if I label it square area? And then circle area is still pi r squared. So pi, what is my radius from the center to the edge? Well, that's half of 10. It's 5. My radius is 5. And if you don't see why I think that's 5, it's because all the way across this circle is 10. I'm given that. So I only went from the center to the edge, so that's 5. So my final answer for the area here, if I multiply out pi, is 78.54 units. Oops, I forgot to put my units in here. Squared. So now I'm going to take my square area of 100 and subtract the circle area of 78.54. And the shaded region is going to be 100 minus 78.54. And my final answer is going to be 21.46 units squared. Okay? So I know we went really, really fast. If you guys have any questions, please make sure to ask me. Thank you guys. Talk to you later.